Z-Transform. Introduction. In mathematics and signal processing, the transform converts a discrete time signal, which is a sequence of real or complex numbers, into a complex frequency domain representation. It can be considered as a discrete time equivalent of Laplace transform. The Z-transform plays the same role for discrete systems as Laplace transform does for continuous system. The Z-transform can be defined as either a one-sided or two-sided transform. First one, bilateral Z-transform. The bilateral or two-sided Z-transform of discrete time signal x of n is a formal power series which is defined by x of z equals summation n ranges from minus infinity to plus infinity x of 1 z power minus n. So here z is the complex number and it can be described as a dot of a into cos phi plus j I sin phi, and j is the imaginary unit. Next one, unilateral or one-sided z transform. So for one-sided z transform, x of n is defined only for n greater than or equals 0. The single-sided or unilateral z transform is defined by x of z equals summation n ranges from 0 to infinity x of n z power minus n. In signal processing, this definition can be used to evaluate z transform of the unit impulse response of a discrete time casual system. Applications of Z-transform. Communication is one of the fields whose development is based on discrete analysis. Different equations are also based on discrete systems and their solutions and analysis are carried out by Z-transform. In the system analysis area, the Z-transform converts convolution to a product and difference equation to algebraic equations. The stability of discrete linear system can be determined by analyzing the transfer function h of z given by Z-transform. Digital filters can be analyzed and digital control system can be analyzed and designed using Z-transform. So mathematical formula for finding Z-transform for given sequence. So z of f of t is n ranges from summation n ranges from 0 to infinity f of n of t into z power minus n, or f of n 1 by z whole power n. Next one, region of convergence. The region of convergence is a set of points in the complex plane for which the Z-transform summation converges. So which is defined in this expression. First example, let x of n equals 0.5 whole power n, expanding x of n on the interval minus infinity to plus infinity, it becomes x of n equals 0.5 whole power minus 3. So because we are using minus infinity to plus infinity. So looking at the sum, which one tends to infinity, therefore there is no convergence here, so there are no values of z that satisfy this condition. So in second one, x of n 0.5 power n u of n, where u is the Heaviside step function, expanding x of n in the interval minus infinity to plus infinity, it will become x of n equals 0, 1, 0.5, 0.5 whole square, 0.5 power 3, etc. By taking the sum, the value will be 1 by 1 minus 0.5 z power minus 1. The last equality rises from the infinite geometric series and the equality holds if 0.5 z power minus 1 less than 1. So hence, region of convergence is modulus of z greater than 0.5. In this case, the ROC is a complex plane with the disk of radius 0.5 at the origin punched. So software used for Z-transform is in MATLAB, you are having this separate tool which is known as Z-trans. So it has the syntax Z-trans f, Z-trans f comma trans variable and Z-trans f variable trans variable. So we can use the trial version also. Next part, illustrations. Find Z-transform for z of 1. So the general formula for finding Z-transform for the function is z of f of n summation n ranges from 0 to infinity f of n 1 by z power n. Before that, we are using, or we can use some standard results. So they are well-known results only. Expansion of 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube, etc. And 1 minus x whole power minus 1 is 1 plus x square plus x cube, etc. Same way, 1 minus x whole power minus 2, 1 plus 2x plus 3x square plus 4 times of x cube, etc. 1 plus x whole power minus 2, the same result but symbols should be changed alternatively. 1 minus 2x plus 3 times of x square minus 4 times of x cube, etc. and e power x 1 plus x by 1 factorial, x square by 2 times factorial and x cube divided by 3 factorial, etc. In e power minus x 1 minus x by 1 factorial plus x square by 2 factorial minus x cube divided by 3 factorial, etc. and minus log of 1 minus x plus x square by 2 x cube divided by 3 x power 4 divided by 4 and so on. Frequently you are using this formula only. 1 plus x whole power minus 1, 1 minus x whole power minus 1 and minus log of 1 minus x. So in this problem, in this illustration, we have to find Z transform of 1. So Z transform of f of n is summation n ranges from 0 to infinity f of n 1 by z whole power n. So here in place of f of n we are having 1. So n summation n ranges from 0 to infinity 1 by z whole power n equals summation n ranges from 0 to infinity 1 by z whole power n. Now expand this expression where n starts from 0 to infinity. 1 by z whole power 0, 1 by z, you have to give the values for n start from 0. 1 by z whole power 2, 1 by z whole power 3 plus etc. So anything power 0 is 1, 1 plus 1 by z, 1 by z the whole square plus etc. Which is of the form, this is of the form 1 minus x whole power minus 1, 1 plus x square plus etc. So in place of x we are having 1 by z here. So if the generalization of this series is 1 minus x whole power minus 1. So 1 minus x is 1 by z, 1 by z whole power minus 1. So taking LCM, z minus 1 by z whole power minus 1. Doing reciprocal, z by z minus 1. The degree should be changed as positive 1. So hence z transform of 1 is z by z minus 1. In the same way, we can find the z transform of k. Same method. So z of k. So z of f of n, z transform of f of n, summation of n ranges from 0 to infinity, f of n, 1 by z power n. Summation of n is equal to 0 to infinity, here k, f of n is k, 1 by z whole power n. Since k is a constant, we can write k times of summation n ranges from 0 to infinity 1 by z whole power n. So 1 by z whole power n, the same result which we have used in the previous result. So k times of z by z minus 1, kz by z minus 1 is the z transform of the constant function A. Next one, third one, z of a power n. So z of a power n, before that I am writing again the formula. Summation n ranges from 0 to infinity, f of n 1 by z power n. Summation of n equals 0 to infinity, a power n 1 by z power n. Here a power n 1 by z power n. Here degree is common, so we can merge these two functions, that is summation n 0 to infinity a by z. We can write this expression as a by z whole power n. After that, expand the summation symbol by giving values starts from n is equal to 0. So a by z whole power 0, a by z whole power 1, a by z whole power 2 plus etc. 1 plus a divided by z, a divided by z the whole square plus etc. So again, which is of the form 1 plus x square plus etc. The generalization is 1 minus x whole power minus 1. So here the value of x is a divided by z. Now I can write 1 minus a divided by z whole power minus 1. So here by checking LCM, z minus a whole divided by z whole power minus 1. So by taking reciprocal, z by z minus a, which is the z transform value of a power n. In the same way, we can find minus a power z transform of minus a power n. So z transform of minus a power n equals summation n equals 0 to infinity minus a power n as per formula 1 by z whole power n. Now we can combine minus a power n 1 by z. So degree is common here. We can combine these two functions as minus a divided by z whole power n. Now expand the summation symbol by giving values for n starts from n equals 0. So minus a divided by z whole power 0, minus a divided by z whole power 1, minus a divided by z whole power 2 plus etc. So this is again the format, in the format 1 minus x whole power minus 1, 1 plus x square plus etc. So here the value of x is minus a by z. Now 1 minus, in place of x I am substituting minus a divided by z whole power minus 1. Minus into minus plus 1 plus a by z whole power minus 1. Z plus a divided by z whole power minus 1. So z by z plus a, this is the value of z of minus a power n. From this we can find z of minus 1 power n. In place of a we can substitute a is 1. So z by z plus 1. We can find z transform for many more functions. So next one, fourth one, z transform of n. Again I am writing the formula z of f of n summation n ranges from 0 to infinity f of n 1 by z power n. So here f of n value is n. So summation n equals 0 to infinity n 1 by z whole power n. Now giving values, start to give values for n, that is substituting the values for n which starts from 0. So 0 into everything is 0, and now substitute n equals 1, 1 by z whole power 1, 2, 1 by z whole power 2, again 3, 1 by z whole power 3 plus etc. So 1 divided by z plus 2 times of 1 by z the whole square, 3 times of 1 by z the whole cube plus etc. From this expression, we can consider 1 by z is the common term. So 1 by z 1 plus 2 times of 1 by z plus 3 times of 1 by z the whole square plus etc. So which is of the form, so 1 plus 2 times of x, 3 times of x square plus etc. The generalization for this series is 1 minus x whole power minus 2. So here the value of x is 1 divided by ez. In this general term, I am going to substitute the value of x. 1 minus x value is 1 divided by ez whole power minus 2, whole power minus 2. So 1 divided by z, z minus 1 by z whole power minus 2. Again, we can consider the reciprocal of this expression. After taking reciprocal, it will become z by z minus 1 whole power 2. Now, 1 by z, this 2 is common for both numerator and denominator. Z square by z minus 1 whole square. Here z and z get cancelled. So z transform of n is z divided by z minus 1 whole square. Next one, z transform of 1 by n. Z transform of 1 by n is, so again, z transform of f of n is summation n ranges from 0 to infinity. First I am writing the formula here. Z transform of f of n, summation n ranges from 0 to infinity, f of n 1 by z power n. Now summation n equals 0 to infinity. Just I am substituting this function 1 by n, 1 by z power n. So here we have to substitute the value as n starts from 0. But if you are giving the first value n is equal to 0 here, anything by 0 is infinity. The entire term will be infinity. So n value starts from 1 here. Because for avoiding the indefinite, that is indefinite term, we are used to give the value from n is equal to 1. Now summation n equals 1 to infinity. I am writing this expression as 1 by z whole power n divided by n. Now expand this summation symbol. 1 by z, here n value starts from 1. So 1 divided by 1 plus 1 by z whole power 2 divided by 2. Again 1 by z whole power 3 divided by 3 plus etc. So in the next step, 1 by z plus 1 by z whole square divided by 2, 1 by z whole cube divided by 3 plus etc. Don't write this expression as 1 by z square or 1 by 2 z square. It is correct only, but we have to map this generalized series. We have to map this series into the generalized standard result. For that purpose only, I am writing this function as it is. So now, which is in the form of minus log of 1 minus x. So the result for this expansion is x plus x square by 2 plus x cube divided by 3 plus etc. Here we are having the same format, x square by 2, x square by 2, x cube divided by 3. So in place of x we are having 1 divided by z. Now the series general term is minus log of 1 minus x is 1 by z minus log of z minus 1 by z. As per logarithmic rule, log n power n can be written as n log of n. So we can, this is 1 only. So we can move this minus 1 to degree as per logarithmic rule. Now log of z minus 1 by z whole power minus 1. Here we can take the reciprocal. Log of z by z minus 1. This is the Z transform of n.